Okay. Yeah, I'm logging in right now. Okay.
That's right. I forgot you had to log out. Maybe
Yeah, don't even worry about
time. Maybe they need like 5 minutes after one person logs out for
it.
something.
I guess so.
I don't
Something
know.
weird like
Just
that.
kind of guessing. But
All right.
if we're talking algebra 3, usually those can be verbalized. If we were talking geometry, it'd be much harder to have you verbalize a problem.
All right. So there's like a bunch of little tiny lessons. Each of them has 10 questions about.
We'll start
But
wherever you would like.
yeah. So right here, this one, the first question I have, I'm trying to make it smaller. All right, here. It says determine whether parentheses 915 is a solution of y equals 12x plus 8.
Okay, how are we going to do that?
Hold on, I'm writing it down. So would we graph it or
No,
because I'm not entirely sure.
the point they gave you was 9, 15. That's the x coordinate. That's the y coordinate.
Yeah.
So if we're going to determine whether this equation has that point on its line, that's a linear equation, a straight line. We'll plug in the y value for y, 15, and we'll plug in the x value for x, which is 9. We'll see if that is correct. Not. That's 108.
Oh, so we just plug it in?
That's all you do, 116.
Okay.
Which is not equal to 15. So if after you plug it in, do I have the right equation? Y equal 12x plus 8?
Yeah, hold on, I'm just double checking.
I'm surprised.
Y equals 12x plus 8.
One that was not a solution.
Yeah, that's it. That's the equation.
Okay.
So all you do is you just plug in the 9.
It was plus 9. It wasn't minus 9. Even minus 9. Yeah, minus 9 doesn't work either, but and plus 15 or minus 15 doesn't work. So, okay, they must have given you one that was not a solution.
Okay,
so
I'm writing this down real quick.
If I were to graph, here, let's go back a second here. If I were to graph this, okay?
Okay.
It's 12x plus 8. If I go over here, I do an xy coordinate. I start at 8. I have a very steep slope of 12. Straight line. Now the question is that point on this line? Well, if I go over to 9, I get 116.
So it doesn't work.
Right. The point that would be on there would be 9, 116. That point would be on the line if I extended it like that. Okay? But that's basically what they're saying. They're giving you an equation that is the equation of a line, and they're saying, is that point on that line? Because every point on that line has to satisfy that equation.
Okay, that makes sense.
What else you got?
Hold on, I'm trying to get out of this. The thing filled up my whole screen, so.
Let's see. You can probably get a little bit more screen if you minimize the.
Yeah, no, I just pressed the wrong button and it like made the whole entire thing show up. So.
But there is a minimize button on that go to meeting panel.
Oh yeah, we're good now.
I got it. So where it doesn't take up much of your screen.
Okay.
Okay, you might want to do that.
The next one we have is parentheses 2 over 3, comma 5 over 4.
Hold on.
And another set we have is parentheses 1, comma 5 over 2.
Just a second.
And the last one we have is
my program was acting up. What was the first point?
It was parentheses 2 over 3, comma 5 over 4.
Okay. And there was a second point?
Yeah, it's a parentheses 1, comma 5 over 2.
Okay. And what's the question? What's the function?
And there's one more solution there. It's a 9x minus 8y equals negative 11. And it says that we have to use substitution to determine whether the given ordered pairs are solutions of the given equation.
Okay, we're going to do the same thing we did last time. Let's take the first one.
Okay, so we're just going to plug it in?
Yep, let's see if the first one works. So tell me what to write. This is kind of the way my tutoring works, is I always try to get you to do the problem.
Sounds good. So the first coordinate in a parentheses is x, right? And the second one's y. So
yeah. So
we plug in.
Tell me what to write. Try to verbalize the next line.
Okay. So it would be 9 times 2/3 minus 8 times 5 over 4.
There you go. That's the way.
Equals negative 11.
Now let's solve that and see if it equals negative 11. Now, do you have a calculator in front of you?
I do.
Don't use it on this one.
Okay.
In other words, the thing you don't, the way to do these problems is not multiply 9 times 2 and then reduce 18/3. The way to do it is to simplify it. Okay, I've got a 9 here and a 3 there. Well, that 9's in the numerator.
The 3 can go in the 9 3 times, so we just get 6 minus.
Exactly, 6. And then the 4 can go in there 2 times.
So we just get 6 minus 10.
Yeah, and that is not equal to minus 11. Yeah. So that's not a solution. Now
okay, so then
again.
9 times 1 minus 8 over 5 over 2 equals negative 11. So then we get 9 minus, so 2 goes into 8 4 times. And then 4 times 5 is 20. Wait, no, it's not. But yeah, it is. So we get 20 equals negative, or we get negative 9 minus negative 20 equals negative 11.
Actually, it's 9 minus 20.
Yeah, that's what I meant.
Negative 11.
But
yeah.
So we just get, that's
you get a little bit of practice at doing something when we do an online session that you don't have a lot of practice at, probably in your whole life. And that is verbalizing this stuff. Because how often do you stand up in class and verbalize the steps of an equation? Probably never. Okay.
Not often, no.
And you do learn something by doing it, like how to verbalize it perfectly.
Okay.
Okay. All right. What else we got?
So the next one is use substitution to determine whether the given ordered pairs are solutions of the given equation.
Okay.
And this one we have parentheses negative 3 over 5, comma negative 2 over 7. And then the next set we have is 0 over, or no, it's 0, comma 1 over 7. And then the equation is 5a plus 7b equals 1.
Okay. And in this case, that's A and that's B. In other words, the difference between X and Y and A and B are just different letters. In this equation, they're letting A and B be the two variables. But if we want to see if these solutions work, this is A, this is B on the upper left. Okay? And let me just point out one thing. A lot of people don't know about this. I mean, this might seem obvious to you, and you might be totally clear with it, but just to let you know. All three of those at the bottom are the same.
Yeah.
Okay, good.
Hold on.
Yeah, I gotta.
So my browser's acting up. Just give me a minute. I'm trying to fix it. It closed on me for some reason.
Your browser closed on you?
I'm getting back
You're not seeing my page. Did go to meeting? Let me pull down my GoToMeeting.
Yeah, I'm on your page right now. I can still see it. I just had to re-log back into my stuff because it.
Oh, that's right. That's where you're getting your problems from. Yeah.
Yeah.
Unfortunately, my eraser, I got to find a different drawing program. I'm using a bamboo tablet, and this program is from Microsoft. I need to go figure out how to get that other, but I'm not going to do it on your time. So let's take the next step.
Alrighty.
First of all, which is the easier one to determine? The first point or the second point?
Probably the second one.
Second one's really easy.
Yeah.
If I plug in 0 for A and 1/7 for B, yeah, that one works. So we know the second point works. Now let's see if the first one does.
Okay.
I'm just plugging in. I find it easier to leave that negative sign out front like that rather than attaching it to the denominator or the numerator. Now, notice they've made this pretty easy. I can divide top and bottom by 5, so that leaves 1. That leaves 1. You get -3. You can divide top and bottom by 7. Now, here it's -3 plus a -2.
So that equals
parentheses around it, just to clarify that. Because if you omitted either one of these, well, if you had the different sign on the 3, that would be a proper equation.
Yeah.
Now it's not. It's -5.
Okay. Let me write this down.
Okay, go ahead.
So this is the ordered pair -5 or -3 over 5 and -2 over 7. A solution of the equation now.
Correct. The other one is.
Okay, it says I have two options because it's A is no, because after substituting it for B, it gives a result of, okay, this doesn't make sense. This is really strange. Just the
what were the original
book is really weirdly worded.
I was doing something.
No, you were doing something right. It's just that it's like asking, it says, is the ordered pair -3 over 5 and -7 or 2 over 7 is a solution to the equation 5a plus 7b equals 1. Select the correct choice below. If necessary, fill the answer box to complete your choice. And it says no, because after substituting for A and B, it gives a result of blank. What's it mean when there's an equal sign with a line through it? I forgot what that means.
That means it's not equal.
Okay. So
in other words, I would say this answer that I've drawn here at the bottom right, that is not equal to 1.
Okay.
Okay. Now, I suppose what they're asking for is what was it equal to? And we got -5. So I think you need to answer that no, because after substituting, it's equal to -5.
Yeah, all right. I fixed it.
That's my guess is what they're looking for.
Okay.
Did they tell you
all right
or not? Or
yeah, it does. It tells you when you get it right.
Okay, so that's what they were looking for?
Mm-hmm.
Okay. And then
you just need to put the answer that you got.
Probably yes is all they even offer, huh?
Yeah.
Okay, cool. What do you got next?
The next one is use the intercepts to graph the equation. But I have a graph on my screen. I don't know if you'd be able to see it.
I don't need to. Go ahead and give me the intercepts.
It says 9x minus 5y equals 45.
Okay. Here's the thing. One of the most important things you can know in algebra. When you're on the x-axis, y is equal to 0, correct?
Okay.
In other words, well, look at my graph. There's the x-axis, there's y, and I meant to make that a point. But that's your x-intercept.
Yeah.
And by definition, y is 0 when you're on the x-intercept. So plug y in for 0. What do you get for x?
0.
You get 5.
Right?
No, plug y in, not 0. Make sure you don't mix it up. The x-intercept is when y is equal to 0.
The x-intercept is when y is equal to 0.
Correct. So plug in 0 for y, solve that equation.
Okay.
You get x.
So would it just be, okay, this equals 5?
So that's the x-intercept, is 5, 0. Notice the y value is 0. Has to be if I'm on the x-intercept, if I'm on the x-axis. Okay?
Okay.
And then when you're looking for the y-intercept, what
Would
must
it just
x
be 9, 0?
No, what must x be?
0.
Okay, plug in 0 for x, solve. What do you get for y?
Y equals 9, correct? Or is that?
No. That goes away. That's the beauty of this, is that when you plug in 0 for a variable, it just totally wipes out whatever is multiplying that. So now you got minus 5y equals 45. What's y?
Wait, hold on. So it's minus 5y equals 45.
Correct.
So it would be 40. Y equals 40.
No, you got to divide both sides by minus 5. In other words, if I'm solving that equation, then I'm doing it by doing the opposite of everything that's affecting y. Right now, y is being multiplied by a minus 5. So I'm going to divide that by minus 5. I'm going to divide the other side by the same thing. Have to do the same thing to the
negative 9.
Totally crosses that out. You get y equal minus 9. Okay? Now, is all that means I drew it in the wrong spot. It's down there. Okay?
Okay.
It's not up above the x-axis. It's below. And the coordinates on that point are what?
Negative 9, 0.
No. X is 0.
Oh, 0, negative 9. 0, negative 9.
There you go. But the key here is now I'm able to graph it. In other words, I have 2 points. That's all it takes to graph a straight line.
Okay. Let me write this down.
Any 2 points. But the x and the y-intercepts are particularly easy to solve for. When you have an equation that is in standard format, which this was, we start out with 9x minus 5y equals 45. That's standard format. It's usually pretty easy to figure out the x and y intercepts. And then you just connect the two dots. And that's your graph. Okay. Now, what did they want you? They wanted you to graph it?
I did the exact graph. It goes through
on your browser?
Yeah.
Okay.
I put it through the exact lines we did, and it said it was wrong. I put it through 5, 0, and 0, negative 9, and it says that's not correct. Yeah, let's wonder why. Let me try again. Maybe I just missed or something. Who knows?
Yeah.
Would it curve, or would it just
be a straight line? It's linear for sure. And the reason I know is because if it was a curved line, one of these variables would have an exponent on it. It would be x squared or y squared or x to the 1/2. But as long as x is to the 1 power and y is to the 1 power, then it's linear. All you need to do is find 2 points. Now, read the original equation to me again. Just make sure I wrote it down right.
It says 9x minus 5y equals 45.
Okay, let's check to see if these 2 points are on that line. Let's check this point right here. Okay, so it's 9 times 5 minus 5 times 0. Is that equal to 45? Yes. So we get a yes there. And if we check the other point, it's 9 times 0 minus 5 times minus 9. Is that equal to 45? Again.
So we get 0, yeah.
So those 2 points are on the line, and they are also the x and the y intercept. So I'm not quite sure what you're doing. It would probably help if I could log in and we'd both be looking at that screen, and then I answer everything in your online browser.
Is there a way I can share my screen or no?
Yeah, actually I can. It's a little cumbersome, but I can make you the presenter. Let me do that. And then I'll be able to see what you're looking at. Maybe I can figure out what you've done wrong. Just a second here. I haven't made anybody else the presenter in a long time. I don't see the, whoops, now I turned that screen off. Audience view. Maybe I need to click on you and say make, wow. Change this program. Let me right click and see if it gives me an option on making you the presenter. Let me see what, edit welcome message. No, I don't want to do that. Gosh, maybe not. Oh, here, let me just settings down here.
I'm looking.
I used to be able to make you the presenter. I don't seem to be able to figure out how to do it on this new program. Here, let me, no, it's just the,
Do you see where it says attendees?
Uh-huh.
On like, yeah, click that and see if you can give it to me from now.
Yeah, make presenter. There we go. Thank you.
All right, can you see my screen now?
It will be in a second. That's one of the reasons I don't use this very much, is because it's pretty cumbersome. Yes, now I can see it.
Yeah. Okay, so the line would go from right here to right here, correct?
No, that's
like that.
That's minus 10.
Oh, minus 10. Oh yeah, you're right.
See why it's minus 10?
I do.
And that's not 5. There's 5. Yeah. 5.
So 5 is like here.
Yeah, exactly. And there you go.
There we go.
Okay.
See, this is the next question right here.
Well, let's see.
Yeah.
Let me graph the equation. I think we can go back to me being the presenter and it'll work better.
Okay.
Just make sure you put it on the right grid spot. Okay, I'm going to go ahead and click back on my name and make presenter, show my screen, and now you'll be back looking at my screen. And I'm going to minimize that. Are you seeing my screen yet?
Yeah, I see your screen.
Okay. And tell me the next equation that it has there.
Y equals 1/2 x plus 3.
This is in what they call slope-intercept format. In other words, you probably remember this. Y equals x plus b.
Y equals, yeah.
That's slope-intercept format. B is the y-intercept. M is the slope. Okay? So if you're going to graph this, where do you start?
You'd start on 3 on y.
Okay.
Then go up 1 over 2.
Everybody says that. I haven't figured out why yet. Every student in Colorado says that. I do not know why. Well, you said go up 1 and over 2. I'm going to go up 1 and over 2.
Yeah.
Is that correct?
2 to the right, like 2 to the right,
There
though.
you go. In other words, I can go over left or right. And
Okay.
I'm not kidding you, every student in Colorado says it the way you say it.
Really?
You have to believe that that's what the teacher says.
That's what they do say.
Yeah. And yet, clearly, which direction you go over is very important, right? I mean, I could also
Yeah.
go down 1 and left 2, right? In other words, if I go from right there and I go down 1 and left 2, I'm right there, which also gives me that same line.
Yeah, I got that answer
You can
correct, by the
go
way.
either way, but you really should specify whether you're going up or down and left or right.
Okay, cool.
Did that work?
Yeah, it worked. That was correct.
Okay, cool.
All right, this one's a little weird.
Okay.
It says, find the distance between the points, give an exact answer of the approximation to 3 decimal places.
Okay.
And the points are parentheses -3, comma 3 and 1, comma 11.
Okay. I'm going to draw this just because there's an easy way to remember the distance formula.
Okay.
First of all, this point is -3, comma 3. And this point, 1, comma 11. We'll put it up there. What they want is this distance right there.
Okay.
Okay. Now, notice that if I were to complete that triangle, that distance represents the hypotenuse of a right triangle.
Oh,
And
okay.
the distance formula is derived from the Pythagorean theorem. In other words, the Pythagorean theorem says that this distance, we'll call it delta x. We'll call this distance from here to there delta y. Well, what Pythagorean theorem says is delta x squared plus delta y squared equals d squared.
Okay.
And what that means is delta x means the difference in the two x coordinates. Delta y means the difference in the y coordinates.
Okay.
Okay? So the exact distance formula, which nobody remembers because it's so complex, that's why I like to teach it this method, is the distance between the x coordinates is that's delta x. Got to
So
square
distance
it.
equals the square root of
Plus the distance between the y coordinates. And I got to square that. And then I got to take the whole square root of the whole thing. So that's a complicated formula to remember. But if you, as long as you know that that distance is always the hypotenuse of a right triangle, and boy, if there's one thing in math you want to continue to remember your entire life, it's the Pythagorean theorem. That's
yeah, for sure.
the most important theorem in geometry. Okay, and that's where if you have a right triangle, the hypotenuse is the square root of the sum of each side squared. And that's what this says. Okay? Now, let's plug everything in. What is x sub 2?
What is it? What is what? I didn't hear that, sorry.
X sub 2. In other words, we've got our distance formula, and that's really where you want to start the problem, is by writing this. But if you have trouble memorizing that, go back to the Pythagorean theorem and realize that this has to be the distance formula.
All right, so to do the x of 2, like, are we doing just x of 2, or are we doing, like,
here we go.
x squared minus x1?
Excuse me. That's x sub 2. That's y sub 2. This is x sub 1. That's y sub 1.
Oh, okay.
Plug it in. What's x sub 2?
X of 2, that is 1.
Minus x sub 1.
-3.
Notice I had to use parentheses, and I have two minus signs together there. I got to square that.
So that's just, okay. So that's
We'll
just 4 squared,
simplify
isn't
it
it?
later. The first step is to get
Oh,
everything
okay.
filled in. Simplifying, it's the easy part. What's y sub 2 minus y sub 1?
It's 1
No,
minus
y. This
-3.
is y.
Oh, y. Sorry, 11. It's 11 minus 3.
Okay, so that's 8. And we have to square that also. Okay? Now,
Okay.
let's simplify it. We're still looking at the square root. First of all, what's 1 minus minus 3?
4.
So 4 squared is 16. Plus 8 squared is what?
64.
So we're looking at the square root of 80 as our distance. Now, their
Okay.
instructions actually gave you opposite instructions in the same sentence. I couldn't believe it when I heard it. They said, give an exact answer and then
Let me read it.
round it off to 3 decimal places. Well, that's not an
Yes.
exact answer. An exact answer is this. Okay, now it so happens that that simplifies to 5 times, 5 goes into 85 times. So that is the exact answer. 5 root 5.
5 root 5.
Hold on. 5 goes into 80 16 times. And 16, the square root of 16 is 4. So root 80 simplifies, and you never want to give that as an answer, root 80. You always
Okay.
want to simplify it. And the way I simplified that, in case it isn't clear, is root 80 is root 16 times root 5. That's what it is. 16 times 5 is 80.
Oh.
And you can always separate. Whatever is inside the radical sign, you can factor it. And that's what we did. And I made sure I found a factor that was a perfect square number. Root 16 is a perfect square number. So that becomes a 4, and then I have root 5. That is the exact answer. Now, you can put that into your calculator and round it off to 3 decimal places, which is fine, but they're not the same thing. That's an approximate answer when you do that.
Yeah, it says use the approximate distance now after we got that.
Okay, so go ahead and put that into your calculator, round it off to 3
It's
decimals.
8.944.
Did it accept it?
Yeah.
Okay.
Yeah, hold on, I'm typing it in right now. We'll see. Yeah, that's good. They
I'm
accepted
not
it.
checking your calculations, so the reason I ask is just to make sure you rounded it off.
Oh, yeah.
Okay?
It's good.
But that's not the exact answer. Had they asked for the exact answer, you would have put in 4 root 5.
Okay, so the next one is the same type of problem.
I'm sorry, what?
I said the next problem is the same one.
Okay.
We only have like 4 problems left, and if we're lucky, we'll finish them before reach 12.
What else you got? What's the next 2 points?
The parentheses are 3.7 and -6.5. 3.7 and -6.5. And parentheses -9.4 and -7.1.
Give me the
okay, so let me look over these all.
Give me the distance formula. What's it equal to?
Okay, so I'm looking over the notes again. So we have to like plug it in. Or it's x1 and x2. I'm just going to write that over the top so I know what I'm doing here.
1 second, Mary. Every math problem, the best way to start it is to write out the raw formula every time.
Okay.
What'll happen is after you do 2 or 3 of them, you'll have it memorized. And then you don't have to write it out every time. But until you have it memorized, absolutely write it out. In other words, the distance is the square root of what goes inside?
x2
in parentheses.
x1, yeah, parentheses x2 minus x1 squared
Okay.
plus y2 minus y1 parentheses. That's squared too, right? Yeah.
Both of them are, yes. That's what the Pythagorean theorem says. In other words, let me just remind you the Pythagorean theorem, okay? That's A, that's B, that's C, that's a right angle.
Yeah.
What the Pythagorean theorem says is that C is equal to the square root of A squared plus B squared. That's the Pythagorean theorem. Well, that's exactly what we're doing here. Is D replaces our C because they're both hypotenuses of these triangles. And x sub 2 minus x sub 1 is side A. That's the difference in the x values. Side B is the difference in the y values.
Okay.
Now, plug it in. Let's come up with a number over here on the left.
All right, so we have D. Oh, I broke my lead. We have D equals the square root.
Let me point out one thing. I don't know. Hopefully this won't confuse you more than help you. But notice that we are squaring each result.
Yeah.
So if I wanted to go x sub 1 minus x sub 2, it would give me the same answer. And sometimes that's a little easier. In other words, this is x sub 1. That's x sub 2. Now, it's only on the distance formula that you can do this. You can't do it if you're doing slope. But if you're on the distance formula, the easier way to do this is 3.7 minus a minus 9.4, right? What's easier? 3.7 minus a minus 9.4 or minus 9.4 minus 3.7. Which of those is easier to do? To me, the top one, easily.
Yeah, most definitely.
13.1. So the difference in the x's are 13.1 squared plus, what's the difference in the y's? And one way to avoid the arithmetic here is just, what's the distance between minus 6.5 and minus 7.1? What is that distance if you were looking at a number line?
Between 7.1 and what else?
Well, here, let me draw the number line. Here's our number line. Here's minus 6.5. Here's minus 7.1. How far is it between those two numbers?
4. Wait, no, it's at 1.4, right?
0.6.
0.6? Okay.
Yeah, in other words, regardless of how I do it, if I subtract the two numbers, I'm either going to get a positive 0.6 or a negative 0.6, depending on which one I put first. But I'm going to get 0.6. Okay. And my point is that it doesn't matter whether it's positive or negative, because we're going to square it. And whether it was 0.6 or negative 0.6 is not going to affect anything. Okay. Now, the only reason I like people to think about that is because it's pretty easy if you're looking at a number line to see that that's a small distance. You're not going to, if you come up with a number like 13.6 as an answer, then clearly you've done something wrong. That's less than 1 for sure between that number and that number. I don't know. I'm pointing with my cursor. I always take a second to realize the student can't see that. But the distance between negative 7.1 and negative 6.5 is what's critical here. And that is 0.6. So that's what we have to square. So do that math in your calculator and you'll have an answer. In other words, you've got to square each number, add them together, and then take the square root of it.
Okay, I'm doing that right now.
Do you have an Inspire, Merrick?
No, I don't.
You have a TI-84?
I have neither of those.
Okay. You're going to have to get a
I should probably get one of those.
You don't have a graphing calculator?
No, I don't.
Well, I was going to say when you get to college, but that they will insist upon you having a graphing calculator. I'm amazed that Highland.
Yeah, I'm going to get one.
at Chatfield, not only do they insist everybody have a graphing calculator, but it has to be a TI Inspire, which is the latest state-of-the-art calculator. It's special.
Yeah.
It's definitely a special calculator, but it's got a pretty good learning curve on it.
I bet.
Yeah, it takes a while to figure it out. But do you have a number for this?
For 13.1, I have 171.61. And for 0.6, I have 0.36.
Add those two numbers together.
Okay, hold on, 0.36 plus 171.61. I have 171.97.
Now take the square root of that. That's your answer.
Okay. And the square root of 171.97 equals 13. Well, yeah, some long number, so we can round it to
4 numbers
13.
after that.
4 numbers. I have 13.1137.
Okay, now round that off to 3 decimals.
13.114.
Yep.
Okay. 13.114.
Okay. What else we got?
Hold on. I think I did something wrong.
Uh-oh. Did it not like that number?
It did not.
Now, let me go back.
Hold on.
I'm not checking these with a calculator. Let's see. When you squared 13.1, the last digit should be a 1. And
Yeah.
when you square 0.6, it's definitely 0.36. I don't know. You want me to get my calculator out and check your answers?
Yeah. Let me get my.
Yeah, if your calculator or if your thing isn't accepting it, it's usually entry error. All right, let's see. I've got 13.1 squared plus 0.6 squared. That's 171.97. Now to take the square root of it. Oops, hold on. I guess I have to enter that 171.97. Oops, sorry. $171.97. I get 13.1137. And it didn't, did the instructions say round off to 3 decimals?
It says give the exact answer and an approximation to 3 decimal places.
I can't tell you what happened. I don't know. I got the same answer you got. So.
Maybe I just typed it wrong. So the answer should be 13.114, right?
Yeah, assuming we have all the correct numbers on our points. Yeah.
Cool.
At least that's what I'm getting. Let me check the math real quick. Yeah, that's 13.1 and that's 0.6. So those numbers are correct. So I don't see where we've done anything wrong.
Let me read off the things real quick.
You want me to make you the presenter again? Let me have a look.
Okay.
That work? Now that I know how to do it, I can do it pretty easier.
Not yet. I don't think it worked yet.
Oh no, I just clicked on it.
Oh, there you go.
It'll work in a second. Okay. 7. That's 13.1. That's 0.6. Give an exact answer and an approximation to 3 decimal places. What you gave was the approximation, not the exact. Okay.
Okay.
The exact answer is the square root of here's the exact answer. Square root of 171 point, what was it, 97?
Yeah.
That's the exact answer. Go ahead.
Oh, that's it. Okay.
Go ahead and put that in.
There you go.
And now give the rounded off answer.
Okay.
That's the 13.114. There you go.
Yeah.
Okay, I'm going to make myself the presenter again. Well, go ahead and advance to the next question. Is this it? R, comma, S?
Yep.
Okay. I'm going to make me the presenter. It's all right if we go a few minutes over on my end. I don't have any problem with it. I don't know if you have someplace you got to go, but.
Not really, no.
So they're saying, what's the distance between R, comma, S and 0, comma, 0? Give me the distance formula without looking it up.
The distance formula is d equals the square root of parentheses x squared minus x, or not x squared, but x2 minus x sub,
x sub 2 is the way you verbalize it.
Okay.
X sub 2,
X sub 2.
What's the rest of it? Oh, and that's squared. You still hear me, Merrick? Seem to have lost audio. I don't know if you can hear me or not. I'm going to call you on the phone. Merrick, you back?
Yeah, I'm still here. Can you hear me?
I couldn't hear you for about 15 seconds, but I can hear you now.
I wonder why it went off like that.
Yeah, I don't know. Every now and then there's audio problems. I can always get around that by just calling you, and I was about to, and the audio came back on. What's the rest of the distance formula here?
Parentheses y2 plus y1
Minus.
squared.
Minus.
Oh yeah, minus y1 squared.
Remember, it's the distance between the two y coordinates. You get distance by subtracting two numbers.
Okay.
Okay, so now plug in.
So we get, hold on, I get 0.
And this
I gotta write down like x minus.
I would advise doing it in reverse. We'll do it both ways. In other words,
okay.
Remember I said you can switch these around? Well, it's easier to do r minus 0 than it is to do 0 minus r.
Yeah.
But you're going to get the same thing. Notice that the first time we do it, I'll do it backwards.
Yeah.
And then I'm going to do it forwards. In other words, this time I'm going to do it exactly as the distance formula says, which is 0 minus r squared plus 0 minus s squared. Notice these two things are the same.
Mm-hmm.
In either case, you get the square root of r squared plus s squared. That's your answer.
D equals r squared plus s squared.
Square root first of r squared plus s squared.
No, yeah, square root r squared plus s squared.
Mm-hmm.
All right, is that the answer? Because there's nothing else you can do from there, right?
Yes, you're right. They can't. There's no numbers to stick in or anything, so that's got to be their answer. Does that satisfy them?
Yeah, I'm still adding it in because this one's kind of really hard to add in.
Oh, okay.
Hold on, just a minute. R
what do you use for the square root symbol on your keyboard?
You have like a little special button you have to push.
Oh, okay, okay. And they
like and so that's why it takes so long.
Yes, I understand. Yeah, I have dealt with MATLAB a lot, and you're right. It's a pain in the butt to pull up their special keyboards.
Mm-hmm. But yeah, all right. Well, that was correct.
Okay, cool. Let me
Cool.
minimize that. We'll go on to, how many more have we got? One or two?
2.
Okay. What's the next one?
It's find the midpoint of the segment with a given endpoint.
Okay.
And the endpoints are -3, -3, and parentheses 3, 2.
Okay. This is easier, a lot easier. I'm going to graph it. There's -3, -3. And there is 3, 2. Okay. So they want the point that's right in the middle.
Okay.
Well, work with each variable separately. What is halfway between -3 and 3?
0.
Yeah, you add them together, you divide by 2. So the x-coordinate of the midpoint is 0. And like I said, the way to find the halfway point is to add the two numbers together and divide by 2. So what's the y midpoint?
That would be 1, 0, 2. No, wait, no, hold on.
Add the two numbers, add -3 to +2.
It would be 1.
No? Add them.
So you add -3 and +2?
It's equal to -1.
Okay.
Now,
-1, my bad.
divided by 2. So that is, you can put it in as -1/2 or -0.5, either one.
I'm going to do -1/2.
Okay?
That's the answer, right? Is there any more work to that?
Nope. That's the midpoints are very easy. You just treat each variable separately. You don't have to treat them in combination. Just find the halfway point between the two x-coordinates and then find the halfway point between the two y-coordinates. And always, the way to find halfway points is to add the two numbers and divide by 2.
Cool. That was correct. All right, we have one more after this one.
Okay.
All right. So this one's a little weird. It says find the standard equation of the circle having the given center and radius.
Okay.
And the center is 5, -8, parentheses, and the radius is 1/5.
Again, all of these problems begin with knowing the standard equation of a circle. Here it is.
Okay.
X minus h squared plus y minus k squared equals the radius squared. If you're going to memorize anything, that's what you need to memorize. That is the standard equation of a circle. And h and k are the center, and r is the radius. So all you do is just plug in. Once you have your standard formula, plug it in. So what is it? It's x minus what?
X minus, what is h plugged into?
H is the x-coordinate of the center.
X coordinate of the center, so it'd be 5?
Yep, that easy.
X minus 5 squared, oh my god. X minus 5 squared.
You don't have to do anything further. You don't have to multiply that.
Okay. Well, I'm not going to yet.
Plus y times, what's the y?
-8.
No, give me the whole thing that's in the parentheses.
5, -8.
Not 5. Y.
Oh yeah.
It's y minus -8. The biggest mistake made in math by people is dropping negative signs, just like you did here. You wanted to turn this into y minus 8. It isn't. It's y minus a minus 8, which turns into y plus 8. So I put y plus 8 in there. And then r squared is what? There's the radius. Square it.
1/5.
1/20.
1/5 squared.
Well, which is 1/20.
Oh, yes, 1/25.
That's the answer. that they're looking for right there.
Okay.
Make sure you put it
And
in.
then,
They give you the okay.
are we gonna have to do FOIL for some of these?
What's that? No,
Or
you
no,
don't have to multiply that out. In other words, what they're asking for is the equation of a circle. Well, that's the general format
Okay.
for the equation of a circle. This is the equation of this circle. This is a different circle. In other words, this is the equation with all the variables that's for any circle. No matter where its center is, no matter what its radius is. The equation of a circle is that. And this specific circle that they gave you, this is the equation of that specific circle.
Okay.
Okay? So the secret on all of these is knowing these general formulas. You need to know the distance formula, the midpoint formula, the equation of a circle, things like that.
Cool.
If your life depended on it, I would say get yourself a deck of index cards, and on one side of the index card, write distance. On the other side, write the distance formula. Another card, write equation of a circle. On the other side of that card, write this formula here. And because there's probably 20 formulas you need to memorize and know by heart that they're not going to give you on these tests or whatever. They're just certain things in math you need to memorize. And there's no better method for memorizing something than with index cards. Now, I know that's a pain in the butt to do, but it works because you learn as you make up the card. In other words, because you're the one making up the index card, you automatically got it half memorized just after you're done making it up. And then if you use them like flashcards, 5 minutes a night, shuffle up the cards and go through them one by one and make sure you know what's on the other side of that card. That's all you need to do. And I guarantee you within a week, you would have all of these memorized perfectly.
Yeah, okay.
That is definitely the way to memorize stuff. That's what Mullen High School does. And I actually told my student, wow, they really force feed you education there. And that's what that is. I mean, my student had to make up 50 index cards over the summer with all of the key formulas that you have to memorize and turn them in. Mullen insisted that the student turns the cards in, then they gave the cards back to the student so they could use them as flashcards. But there is no better way to memorize stuff than that method right there.
Nice.
Yeah. So that take care of you for today, Merrick?
Yeah, that'll work for today.
Okay. And then we have another session, I think. Here, let me just check the calendar.
It's on Sunday, I believe. It's tomorrow at like 1:30.
Oh, it's Monday.
Oh, Monday? Okay.
1:30.
Monday 1:30, cool.
I could do tomorrow if you want to switch it. No, I can't. Well,
no, it's not a big deal. I just got my times mixed up.
Okay. So I will, now, the next time, I won't call you. I will just text to you the meeting ID number.
Okay, cool.
Okay? You don't need my help anymore as long as you have that icon on your desktop that you double click on and it asks for the meeting ID number, and that's all you have to do, and next thing you're in a meeting. You won't even have to change your audio settings. The only thing you might have to do is unmute your microphone when you first come into the meeting. Remember to do that. I will. Okay?
All right. Thank you for your help today. I appreciate it.
Nice working with you, and I'll talk to you Monday.
Okay. See ya.
Oh, to close out and go to meeting, yeah, you just close out of the X at the top. You know how to do that.